Right. You see, the classical spanning tree, the common spanning tree, timer based, common spanning tree protocol. But we don't put that C in front of this usually. We say IEEE 802.1d spanning tree, which is nothing but common spanning tree. This is a timer based. Same like per VLAN spanning tree protocol. Both are timer based. The only difference between these two is every VLAN have got a separate spanning tree. And this is Cisco standard. And now we have rapid spanning tree protocol, which is IEEE 802.1w, which every vendor have got this. Cisco also got it, but a modified version. What Cisco got is RSTP PVSTP plus. So when you enable RSTP in Cisco, this is what gets enabled. It is fast, unlike this. This one is slow. This is fast. No timer based. The difference between this and this is, you know it, only one spanning tree, only one rapid spanning tree for all VLANs. Here, each VLAN per VLAN, each VLAN have got rapid spanning tree. So this is again Cisco. In Cisco, this is default. In most of the device, especially in all of the enterprise device in Cisco, it is per VLAN spanning tree default. And when you enable rapid spanning tree, it is going to enable this one, not this one. This you can find in Juniper, Huawei, ZTE, and other more, much more. At last, we have another one which is also not a timer based, called MST, which is IEEE 802.1s standard. When you enable MST, by default only one MST for multiple VLANs. That is why this M, many VLANs, all VLANs. And that is called as MST instance 0. MST 0. But you can say I am going to have instant 1, VLAN number 1 to 50. Instant 2, VLAN number 51 to 100, and so on. With MST, we can decide how many instant of MST we will run. If you have two paths to load share, we will have only two instances. I'll explain you in detail as we are going to go through the lab. Now, we have these types of spanning tree. You know the first one, and now I'm going to explain this one more time per VLAN spanning tree protocol advantage. Because you got each VLAN a separate STP. Whenever we have multiple paths like this, switch we should draw like this, a rectangle box. Whenever we have multiple paths, switch 1 to reach switch 4, you have two paths. Switch 2 to reach switch 3, you have two paths. And you got some VLAN 10 members, VLAN 20 members, VLAN 30, VLAN 40, VLAN 50, VLAN 60, VLAN 7, VLAN 10, VLAN 30, VLAN 50, VLAN 20, VLAN 40 members. You see, the VLAN members are in all switch scattered. You may have some VLAN 60, members of these VLANs are everywhere. Now, if it is common spanning tree, there will be only one spanning tree. And if that one spanning tree blocks here, what does it mean? It is blocking for all VLANs 10, 20, 30, 40, 50, 60. Which means if this alpha wants to talk to beta, it has to take this path because there is a block. See? Now, what we can do, we can load share so that I will have a block here only for VLAN 20, 40, and maybe 10. And I'll have block here for VLAN 30, VLAN 50, VLAN 60. So now let us try to understand. If VLAN 10 is talking, it will only talk to VLAN 10. So the path taken is not the below path because the below path is blocking 10. It will take this path. This is not blocking for VLAN 10. Now, if VLAN 60 want to talk, it won't go via the upper path because there is a block. It will come like this. Next, if VLAN 20 want to talk, because there's a block in the bottom, it will take only this path. It won't come via the below path. Now, if 50 wants to talk, it has to go via this path only, because 50 is blocked here. And if 40 wants to talk to the remote 40, because there is a block here, it will take only this path. And if 30 wants to talk, because there is a block in the upper path, the 30 have to go like this only. But if you want to change, you can do something like this. You can block 30 down. So that's what planning is. You should do planning so that it won't take long route. You try to analyze, block here 30 also. So the 30 will go this way. See, we are using all paths here. No paths are idle. There is no paths idle. One path is blocking 50 and 60, but allowing 10, 20, 30, and 40. The other path is blocking 20, 30, 40, 50. Sorry, 20, 30, 40. The other is, blocking 20, 30, and 40 and permitting 40 and 50 and 60. 50 and 60. By doing so, we are doing manual load sharing. This is manual. This is not automatic. We only plan and say where, which VLAN to block. How did we do this? For all these VLANs, we set priority lower. The default priority is 32768 on all the switches, but we are going to say for all these VLANs, priority 0. So definitely, for all these VLANs, we set priority 0 here. In this switch, we set priority 0 for VLAN 20, 30, 40, 40, and 10. So that this will be the root switch. Root switch won't block. Root switch won't block for these VLANs. This is the root switch, so there won't be a block. And on switch 3, we say priority 0 for VLAN 50 and 60. So then for V50 and 60, it will go through this path and blocked on the upper path. See, if it is single VLAN, single STP for all VLAN, this is not possible. If I have only one STP for all VLANs, I cannot give different priority for different VLANs. Per VLAN spanning tree advantages, I can have different priority for each VLAN. I'm going to show you this. Sai, did you understand this now? Per VLAN spanning tree protocol. So on the packet tracer, I'm going to build Similar topology which we had in the discussion. Switch 1. Now I don't know which switch has got the small MAC address. One among these 4 will become the root switch based on the MAC address. The default is 32768. The default spanning tree that is running is per VLAN spanning tree. It is per VLAN spanning tree running. But you have only one VLAN as of now. I'm going to create that 6 VLANs on all the switch first. And then put this links as a trunk link. According to me, this switch may be the root switch now. Let me go check because there's a block here. Let me go check. It's all because of the priority. Sorry, MAC address, show spanning tree. Yeah, as I guessed, this is the root switch. So for our better understanding, I'm going to put the root switch on the top. Yes. Switch 2 is the root switch. It is because of the small MAC address. Let me copy the MAC address for you. The priority is default 32768. There is only one spanning, the one VLAN. Because of the one VLAN, there is only one spanning tree as of now. After I create more VLANs, you will see more instance of spanning tree here. Before that, let me copy this MAC address. And you already see this says this is the root bridge. Hey, MAC address, copy the MAC address. Copy. Root switches will never block. They always forward, designated to forward. That's what we learned in CCNA, right? So next is I'm going to copy the MAC address from here. I'll give a host name to avoid confusion. Show spanning tree. This is the MAC address. Switch 4. This is the one which has got the biggest MAC address. That's why it is blocking here. After I paste MAC addresses, we can compare. I need to wait for some time. I did not type IP, no IP domain lookup. So it's looking into the domain name, domains for config. I should have put space. Meanwhile, we'll create the VLANs, VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60. See, on the real device, you don't need to create 10 separately, 20, 30. You can put comma here. After 10, comma 20, comma 30, comma 40. Just one line you can configure. Right, I'm going to copy this to other switches. 10 and 20 I need to copy. Only 11 lines it will show you. VLAN 10, VLAN 20, and paste the remaining. Done. This switch name is okay. Let's go to the switch one and name it first. Host name switch 1. All right, VLAN 10, VLAN 20, and paste 30, 40, 50, 60. Done. Likewise, I'll do it on this switch. VLAN 10, done. We have configured VLANs. Show VLAN brief, you can see those 6 VLANs, but no interface membership. No interface is mapped. Also on switch 3, show VLAN brief. We have those VLANs, but no interface mapped. Switch 2, no interface mapped. Switch 1. So we are going to map interface maybe later. I want to show you that for each VLAN, there is going to be a separate spanning tree. But when there is no interface on these VLANs, what is the use of that spanning tree? That is why you don't see now. Show spanning tree. You don't see now. Still, you see only one VLAN. You don't see 10, 20, 30, 40, 50, 60 that we created. The reason is there is no member. If you want to see, you can connect computers to different VLANs, then it will come. Or make these links as trunk link. You remember, a trunk link is a link that is part of all VLANs. So I'm going to configure trunk, and then I will take you to show spanning tree command. Right now, it is not showing all VLANs and separate instance for each VLAN. But after I put these links as trunk link, you will start seeing multiple spanning trees. Let's do it. If I configure trunk on this 2 link, this other end will automatically trunk. Any question on this? If I configure trunk on one side, the other side will automatically trunk. Can anyone say how and explain? Correct. Who said this? Hi Venkat, welcome. So it is dynamic trunking protocol negotiation, which is dot one Q, isn't it? Dot one Q negotiation. Dynamic trunking protocol DTP protocol is dot one Q. DTP is not a protocol name. DTP is just a term to say through negotiation. Now, what I'm going to do is I'm going to configure trunk on this side, and this side it will become trunk automatically. But I'm not fully satisfied with that simple answer. I want more explanation from someone else, not from the same person. If I configure trunk on one side, the other end is trunking. Venkat said, yeah, it is because of negotiation. The other side became trunk. I agree. True. But for the negotiation to be successful, there is something there on switch 2 F02 and switch 4 F01 by default. What is that? Dynamic auto. Very good. Because this is dynamic auto on this side, when other side is configured as trunk, DTP goes and negotiates, dot one key protocol goes and negotiates and convinces the other side to be trunk. Now let's do it. On switch 3, I'm going on both the interface at the same time because I have only one configuration to do on both, which is switch port mode trunk. Likewise, I'm going to go to this end of the topology, switch 1, these two ports, I'll make it as trunk so that this 2 port will also trunk. Switch 1, switch port mode trunk. As a result, this will trunk. I'll show you. Show interface trunk. You can see this is trunking, and it is allowing all these VLANs now. Let's go check here. Even here you can see this is trunking and allowing all these VLANs. And this is statically made as trunk by us. Show spanning tree. Sorry, no. Show interface trunk. This is trunking because we turned on the trunk, after which this dot one Q went and negotiated with the other switch. Now we got many VLANs mapped to these 2 ports. So I should see different instant of spanning tree for each VLAN. Show spanning tree. You see, I can see one instant on the top. This is for VLAN 1, and another instant for VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60. For all these VLAN, if you see, for VLAN 60 also it is designated and root. Designated, root. Same role it is doing for all VLANs. Because we did not set different priority, as a result for all VLAN, this is the root switch. You want to see? Go to that switch and ask. Show spanning tree for VLAN 10. It will say, this is the root switch. Okay, show me for VLAN 60. For that also, this is the root bridge. Okay, show me for VLAN 40. For that also it is a root bridge. You can type individual VLAN like this, or you can simply type show spanning tree to see page by page. 10, 20, 30, 40, 50, and 60. For all VLANs, this is the root switch. As a result, for all VLAN, this is blocking. You want to see that? Switch for show spanning tree for VLAN 60. It will say I'm blocking on F01. Okay, what about 50? I'm blocking. What about 40? I'm blocking. What about 30? I am blocking. And see the priority. 32768 plus 30. 32798. When you add 30 to this. You see the VLAN 20? 32768 plus 20, which is 32808. Sorry, 40 for VLAN 40. For VLAN 20, 32768 plus 20 is 88. And you see, same interface is blocking. So for all VLANs, this one port is blocking, which means none of the VLAN traffics can go through switch 4 because it is blocking for all VLANs. With the help of per VLAN spanning tree, we can make some VLANs to go via upper path, some VLAN to go via below path. Right? So what I'm going to do is I'm going to connect six computers on each side. One for VLAN 10, 20, 40, 40, 50, 60. This is going to be VLAN 10. IP address will be 10.0.0.1/8. VLAN 20. I'll put simply V20 20.0.0.1/8 because the space is too much, it takes. And VLAN 30. Okay, to maintain the hygienic view, let's take only 4 VLANs. Though we have 6 VLANs, for testing we'll only use 4 VLANs. So VLAN number VLAN number 10, 20, 50 will go this path. VLAN number 30, 40, and 60 will go this path. That is what we want to achieve. Meaning, I want a block for 30, 40, 60 on the top path, and I want a block for 10, 20, 50 on the below path. Right now, block is in switch 4 for all VLANs. I don't want these VLANs to be blocked. Likewise, on the upper path, other than these 3 VLAN, all others should block. This is what we are going to achieve so that load sharing can be done. See the name of the interface F03 should be in VLAN 10. Let me configure parallelly. Interface F0/3 switch port mode access switch port access VLAN 10. VLAN 10 is already created. Next, I'll connect this computer to F04, which is VLAN 20. Interface F0/4 switch port mode access switch port access VLAN 20. Interface F0/5 switch port mode access switch port access VLAN 30. So this is going to be connected to 5. Done. And this one will be connected to 6. Which is VLAN 40. F06 switch port mode access switch port access VLAN 40. Now let's verify this. Show VLAN brief. You can see 10 has got a member, VLAN 20 has got a member, 30 has got a member, 40 has got a. Right, this is the plan. Let's put the IP address quickly. Inside, I have not configured these computers with IP address. We just only planned in the whiteboard. Okay. Right. So next is we are going to have another 4 computer on the right side. This is VLAN 10 10.0.0.2. VLAN 20 20.0.0.2. VLAN 30 Okay. Now, same 03 will be 10, 04 will be 20, 05 will be 30. 06 is going to be for 40. So because it's the same configuration, I can copy from this switch because it's the same interface names. I can copy and paste instead of doing it. Show run. I'm going to copy from interface 3, 4, 5, and 6. Easy. You can copy like this. Nothing wrong. And go here and paste. Done. How easy it is. Now let us verify. Show VLAN brief. You see 3 is connected, configured to VLAN 10. 5 is configured to VLAN 30. 5. 5 is this. Yes, VLAN 30. And 6 is to VLAN 40. Correct. So we got the VLAN membership, we got the trunk, and now we are going to do load balance. Right now, because there is a block here, all these PCs, see, I'm going to ping. Ping -T means, timelessly, without stopping. Keep pinging 10.0.0.2. It's going to ping. It'll ping. The Mac learning is, oh, no. Why it's not pinging, We didn't configure the IP address on this PCs. Now it will ping. You go and see. You see, it's pinging. Let's also go to these computers and put the IP address. And this one. Right. So next what we are going to do is we will start pinging from here also to the remote. Ping -T 20.0.0.2. Here also you ping -T 30.0.0.2. And this one, ping -T 40.0.0. Now, if you see the blinking is not happening, mostly it will happen only in the upper part. This small blinking is BPDO. But the big blink, there's a block here, you understand? There's a block for all VLANs. And all the traffics are now going via the upper path. There is a way to prove this. If I cut the wire here, all will drop the packet. And all the traffic will start going via the below path after 50 seconds, 50. That's the proof. I'm going to cut the wire now. You see, I cut the wire. And you see how long it takes for this to become green. I'm going to show you for one VLAN. Show VLAN 30. Show spanning tree for VLAN 30. You see, it's in blocking. Wait 20 seconds. After 20 seconds, this will say learning. because the timeout should happen. See, now it is listening. In listening, it will be 15 seconds. See, blocking, now listening, and then after 15 seconds, it will go to learning. LRN, learning, and then only it will go to forwarding. Still it is learning the new methods. Okay, now forwarding. Now if you see anything, you will see a lot of, see, VLAN 10 has dropped, VLAN 30 also has dropped, VLAN 40 also has dropped, VLAN 20, every one has dropped, which means all VLANs were going via the upper path earlier. So now all shifted to the below path. Now I'm going to connect back the wire. They will all go back to the upper path. So again, all will drop. VLAN 10 start dropping. VLAN 20 also started dropping. VLAN 30 and VLAN 40, which means all are sailing in the same boat. Now all are trying to move to the upper path because there's a block for all VLANs now in switch 4 as soon as this link come up. This has taken the root switch. You see, it is green. Now all started pinging now, all at the same time, which means all are going via the same path. We don't want this. We want to load share. As I said, for these three VLANs, I'm going to set priority zero, so that this will be the root switch block. And for this VLANs on switch 2, I'll make priority 0, so that there won't be block for these VLANs only. Okay, let's do. Because before checking the MAC address, it will only check the priority. MAC address is needed only if there is a tie-in priority. Okay, I'm going to do it now. You see, I'll go to switch 4. Right now for VLAN 30, 40, and 60, you see here. VLAN 30, it says blocking. This is not a root switch. VLAN 40, it's blocking. VLAN 60, it is blocking. But when I put the priority as 0 here, see what happens. Spanning, this is the command, spanning tree for VLAN 30, spanning tree for VLAN 30, priority 0. And for VLAN 40, 0. And for 60, 0. Done. 30, 40, and 60, I made priority 0. Now I'm expecting this to become a root switch for this 3. Let's go verify now. Shows, I used the same commands earlier. I'm using the up arrow. See, now it says this is the root bridge. Because the priority is changed to 6, the total priority is only 0 plus 60, 60. The priority is 0. So this is the root switch. Right now it is in the learning state. And for 40, not for 40, yeah, for 40, again we set the priority 0. And for 30 also we made priority 0. So this is the root bridge for 30, 40, and 30, 30, 40, and 60. For 50, this is not root. See, for 50, this is blocking only. You understand? For some, this is blocking. For some, it is forwarding. Now, already this was forwarding for all VLANs, but to be on safer side, I'm going to set priority 0 for 10, 20, and 50. Needed, not needed, but just to be on safer side, spanning tree for VLAN 10. This is already a root, but I'm simply, for my satisfaction, I'm saying priority 0 to make sure no other switch will be the root switch for 10 and 20 and 50. Okay, now let's verify. For VLAN 10, our expectation is to go via upper path. It is going. VLAN 20 also going. For VLAN 30, we are expecting to go via the below path. It is going, but we need to make sure it is going via the below path. For VLAN 40 also it is going. Now, if I cut this wire, only two PCs should get disturbed. What are they? If I cut this wire, only this PC 30 and 40 should get disturbed. That proves that they were going this path earlier. After the cut, it is trying to move to the other path. Did you understand, everyone? I got only 2 years. Okay, so now I'm going to disconnect. If I disconnect, first two PCs should not get disturbed. You see, this is still pinging happy. And this also still pinging happy. What is getting disturbed is only 30 and 40, which means these two guys were moving on this path. Now, because of the disconnection, they want to move to the upper path. You see, 20 and 10 has got no problem, which means 10 and 20 was going via the upper path. Only this 30 and 40 was going via the below path. Now it is trying to move to the upper path. It will move there up. It will take time, but it will move. "50 seconds it will take to converge." Yeah, it started pinging, and now it is taking the upper path. If I connect the wire back again, only these two PCs should get disturbed. See, again this will get disturbed. You're going to see now, which means the upper path says, I'm not going to allow you. The upper path has said, I'm not going to allow you. So it proves that only for these two it is coming down, but for 20 still pinging happily, no problem. For 10 it's still pinging happily, no problem. Only for 30 and 40 the below path is used. This is what the advantage of running more than one spanning tree protocol. In common spanning tree, this is not possible. This is not what is not possible, to load share across the multiple links. Only the per VLAN spanning tree is possible. So what we have seen today is the slow convergence per VLAN spanning tree protocol. I have much more to teach about the priority that will be covered in the next class, but you should be very well clear with this concept of per VLAN spanning tree and the advantage of per VLAN spanning tree by this today's class. Do you have any question in what we have covered today? Okay, I heard only one. Okay, okay, good. Go through this